Hello students, welcome to the Chemical and Physical Change Lab. We're going to do some demonstrations that the students normally would have done in class and just get you a feel for, is this a chemical change or physical change, and is there a conservation of mass, which hopefully we should have conservation of mass. That shouldn't change probably. So we're going to do 6 different demonstrations, and we'll have you write down your results, and you're going to do a CER, a claim, evidence, reasoning, later in the week on Tuesday and Wednesday. So you do want to record your results. Okay, so first one, very simple one. Just working with steel wool. In case you don't know what steel wool is just this meshy iron. It's just basically iron. And get the mass first, mess with it, then get the mass again. See if the mass is the same. Okay, so I'll put it on there. So right now it's registering 1.48 grams. All right, and then we're just gonna mess with it. I'm just gonna bend it, twist it, let's kind of fluff it out a little bit, squish it back in, and now I'll just put it back in the scale again. That's 1.47 grams. Yeah, so I did lose a little teeny bit here. You can see this little, when I was moving it and stuff, a little bit came off. Actually, let's just see if this works here. Let's just put all this on there and see if it goes back up to 48. Just out of curiosity, I'll put it onto this matchbook. And yep, 48, okay. So it seemed like I had lost some mass, but looks like I didn't. Cool. So that was demonstration number 1. Okay, so sample number 2, or experiment number 2, is going to be looking at some ice and melting ice. When it melts, there's going to be a different mass. So of course it's going to be making liquid, so we have to trap it in something. So I'll use this Petri dish, put it on there, and I'll keep the mass of that and put some ice in there. And right now it's registering as 62.40 grams. Then we will take it and put it on this hot pad. It's a little hot pad. It gets nice and warm, just to speed it up a little bit. And we'll see it, hopefully see it melt. There you go. It's just kind of. Okay, now again, you gotta ask yourself, is this a chemical change or a physical change? It was water in a solid form before. Now it's water in liquid form. Okay, so now you ask yourself, should it be the same mass or heavier or lighter? Let's see. Okay, so it's melted appreciably. We can probably take it off now. It's half melted, so if there was any change, we'd see it by now. So let's just unplug that and pull it over here, and it is 62.37 grams, hovering at 62.38. It's sort of hovering at 3738 before too. Sometimes that last digit, if the last digit's off by 0.01, little breezes or a little bit of dust, if it's within 0.01, it's probably good enough for our calculations and stuff. So experiment 3, we're gonna make a precipitate. This one I'm gonna have chemicals for, so I'll get my goggles on. And we're gonna take 2 chemicals, some calcium chloride and some sodium hydroxide. Now these are solutions. We talked about homogeneous mixtures last week. This is a crystalline substance, calcium chloride, like a rock or a salt. We put it in the water and stirred it, and it made a clear solution. But there's now 2 things in here: it's water and the calcium chloride. So it's a homogeneous solution. Same with this. It's sodium hydroxide. Sodium hydroxide is a white crystalline substance. Put it in there, stir it. So it's actually 2 things in here. So they're both homogeneous mixtures or solutions. So but these guys, when I mix them, they will make a precipitate. Something from here and something from here will stick together and make a little solid white powder. So right now they're both clear. I need to get some masses. So I'll put this in here. Let the scale start up, and I'll put that on there, and I'll pour some calcium chloride in one of them, sodium hydroxide in the other one, And then we can check the mass. Okay, so it's holding at 123.67 grams. So it's just 2 test tubes in a beaker. The beaker's just there to hold it so it doesn't tip over. It's kind of hovering between 6.6 and 6.7. Okay, so we're ready to pour it together. We need an actual chemical reaction now. So this will be an actual chemical change. So clear and clear. Normally, if it's just physically blended, it should just be clear. You know, clear and clear should be clear. But if I do this, what? It turned white. It's a white precipitate. So what happened is the calcium from this one and the hydroxide that was in this one like locked together. They magnetically stuck together, and which is they chemically interact with each other, and now we have this precipitate. Okay, now is it heavier or lighter than before, or more or less massive? Okay, let's check the masses. Okay, so we're holding at 123.66. Again, it's kind of hovering between 6.6 and 6.7 before, so it's still, so it's the same mass. Okay, make sure you're recording your results. Record write down your descriptions and stuff, what you're seeing, you know, what made a white precipitate, white powder and stuff. And this is kind of interesting. You'll see more precipitates later on. We'll go over double replacement reactions. It's a form of double replacement reaction. And it's kind of like a snow inside. It's starting to settle down. The white precipitate's denser than the water, so it'll settle down. Eventually, you know, give it a couple hours. It'll be like a little plug or a little powder on the bottom, like some sand in the bottom. Cool. All right, reaction 4. So reaction 4 will be burning steel wool. So before I just kind of warped the steel wool and didn't do anything with it, now we're going to actually chemically change the steel wool. I'm going to rust it. So I have this basically piece of iron, and there's of course oxygen out here. What will happen is if I hold this in the fire, so Bunsen burner here, the oxygen and the iron will combine to make iron oxide. That's what happens in your car or a nail or something outside when it rusts. It'll pick up oxygen from the atmosphere and make iron oxide, iron 3 oxide, Fe2O3. Okay, so first of all, I want to mass it. Then I'll put my little pinchers and I'll burn it. And we'll kind of collect the ash, because it's going to kind of spread out little ash and stuff out. So I'll collect the ash and put it in here. So I'm going to put it inside this little Petri dish. So with the Petri dish on it, it's 0, and I'll put the steel wool in there. It's about 0.35 grams, very light, very fluffy. Okay, then let's burn it. Okay, you can see it's kind of spreading out. This is basically how sparklers work, the fireworks sparklers, the lamest firework ever. But it's just the iron is burning with oxygen. And you can see where it's glowing, it's actually rusting. It's picking up oxygen. Now you notice little pieces did fall off onto the counter, so I'll have to collect those. If I don't collect those, that would be like, oh, the conservation of mass is wrong because, you know, we lost mass. But we'll collect those pieces as best we can. Kind of see you can see those little sparkles that come off it. That's like the sparklers. You know, basically, what sparklers are, the super awesome fireworks sparklers, those are just like the gunpowder type mixture in a paste with the iron filings in it, and then when the gunpowder burns, the iron filings fly out like the little sparks that come off of there. Okay, that'll probably be good. Let's just let that cool for a second. And right now it's 0.35 again, but wait, there's still some stuff over here. So it's basically the same as before, but now I can get all these little pieces that fell off. Get this on as best I can. What? It's heavier. Conservation of mass is wrong. No, there's a reason for it. I'm not going to tell you what the reason is, but you can figure out the reason. Yeah, so that's demonstration number 4, burning steel wool. Demonstration number 5. We're going to put some sugar in some water and just dissolve the sugar. You've all done that a million times. So I have a system here. I'm going to take the beaker I'll dissolve it in, and I also have some water in a cylinder, and because the water will be in the cylinder, I want to make sure all the masses are right. So I'm going to mass the whole thing. Then I'm also going to have a stirring rod, but because the stirring rod, things will cling to the stirring rod, I'll make sure I mass the stirring rod before and after. So notice I'm massing everything before and after, so we don't have any, if I don't leave the stirring rod in there, it's like, oh, the mass is different. So this is a controlled experiment. You got to make sure everything's taken into consideration. Okay, so let's look at the mass and put some sugar in here. Okay, so with all the stuff in there besides the sugar, so I got the sugar here, good old C&H pure cane sugar, or crystal sugar. We're gonna, so it's that mass right now. Let's put a little bit of sugar in there without spilling it. Okay, so that's just everything there now that we should ever need for this experiment. And it's at 186.13 grams. Okay, so now keeping that there, we'll just take the water, oops, and pour it in there. Okay, well it's lighter now because everything's on the scale. Making a solution, a sugar solution. It's going to be water and sugar. And it'll take a while to dissolve. Maybe we won't. Almost all dissolved. I guess we... Yeah. Okay, let's check it out then. And 186.12 grams. Okay, I hope I didn't spill any or splash any out, but okay, cool. That's experiment 5. Okay, so we're on experiment 6. Remember to be recording things in the documents. Make sure you're getting your masses down and writing some reasoning down. Again, you'll be doing a CER, claim evidence reasoning, for this lab next tomorrow and Wednesday. Okay, so the last one is going to be then some Alka-Seltzer or some generic Alka-Seltzer, which is just a tablet that foams in water, and it's good for soothing your throat and stuff if you have a cold or something. So I'm just going to take a half a tablet and some water. Not sure if anybody's ever used this before, but just you put it in there, it'll effervesce, give off carbon dioxide bubbles and stuff, and then you drink it. It's kind of soothes the throat and stuff. So I'll put it on there, and I'll put the Alka-Seltzer also on there, and we're actually gonna react it on the scale, so we can in a real time see what's actually happening with the with the mass of everything in this reaction. Okay, so I'll put this on there. Let's get the mass. So right now we have 183.40 grams. That's the piece of the Alka-Seltzer, generic Alka-Seltzer is there. Okay, let's drop it in and see what happens. Now remember, when we made solutions before, it was always the same mass. Okay, it's fizzing. All right, and it was at 0.40 before. Look at the mass. Wait a minute, is at 0.40 before? 0.36. 0.35. What? Are we breaking the conservation of matter rule? Man, we're destroying matter. That's not good. Well, that's a reason for it. You guys, I'm not going to tell you the reason, but you can figure it out, I'm sure. So it's actually lighter. It's about 0.06 grams lighter than before. Okay, and there has to be a natural reason for that. The law of conservation of mass can't be broken. So, okay, so those are our 6 demonstrations. Some of them were pretty obvious what happened. Some were like, what? That didn't make sense. So, okay, so we'll, again, in class, just get your results down and file that document away in Notability. And we'll do the write-up on Tuesday and Wednesday this week. Okay, bye.